Good evening, all. Good evening. Good evening, and welcome to our second day of our AI workshop. I hope in the previous session we have seen a wide range of introductions, topics about AI and different fields of it. So in this session, first I'll be showing you an output of this particular project, which is traffic sign recognition automatically with the help of image processing and neural networks with AI. And once I shown you the output, I'll be taking the session on how this could be achieved and what is the concepts used behind it. Obviously, deep learning is utilized here. So I'll be taking time on explaining how that thing actually works. Okay, so you can't go in depth in this 1 hour of everything which works in the backend. We'll see how the process goes on. Okay, so can we start with the session? Good evening, guys. Good evening. Yeah, so I hope I could show you this output. So this is a traffic sign recognition. So these concepts are actually used as a part in our nothing but, like, for example, auto driving cars and Tesla cars, right? So they have this things like traffic sign recognition. So based on that, they will be having some limitations, or they have to obey that particular command. So that's what this traffic sign recognition is used for. So let us build, or let us see an output of it. So first, this has been used as a GUI here with something known as Python tkinter. So you won't be going into that part, but this is how the output looks like. For example, if I run this and get you the GUI, okay, so this is what that particular app is. Okay, so in the backend we have our traffic sign classification model from our deep learning. So this is a prototype, which means it is not integrated in video. If you have it in video, this will run. Anyway, video is nothing but images. But for manual verifications, we have done it as, for example, you could click and upload an image. So here I have a bunch of traffic signs, right? So for example, let us go and select one traffic sign. Let us click this. Okay, so this is the image, and I could click classify image to find. Okay, so this is founded as ahead only. Okay, so let us upload some other image. Let us go with this, classify this image, general caution. Okay, so let us go with this image 30, classify this image, speed limit 30 km/h, right? 50, let us go with this, upload. Okay, uploaded already, classified, speed limit 50 km/h. So let us go and implement, try it in some other images. For example, let us go with this, classify it, turned right ahead. Okay, so this works really great, right? Any comments on how this works? So this is what integrated when you do it in live feed from a video. It can be helpful for detect the signboards. So based on that, based on the traffic sign or the signboards, they could go and like, for example, if it is turned right ahead, so they need to understand the algorithm will be designed in a way that so it listens to these tasks and take decision based on it, right? So that's how AI is implemented. So is it clear about how this works? So the usage of it, if it is good, then I can go and show you, okay, how to create actually one of such thing. Okay, so an overview of how these things are built. So let us start this traffic sign recognition. We'll see some introduction, objective, the data set, and the workflow. Okay, so talking about the introduction, in this era of AI, humans are becoming more dependent on technology, and with enhanced technologies, multinational companies like Google, Tesla, Uber, Ford, Audi, Toyota, Mercedes-Benz, and many more are working on automating the vehicles, right? They are trying to make more accurate autonomous or driverless vehicles. You all might know about self-driving cars, right? So where the vehicle itself behaves like a driver and does not need a human guidance. And researchers are running many algorithms to ensure 100% road safety and accuracy, so that any accidents can be prevented. At the same time, auto driving can be implemented. So one such algorithm which is implemented, which is helpful, is nothing but traffic sign recognition, which we'll talk about here. So this data, so once again we have image data set. Okay, so if you want to train your algorithm, you need to have image data. Here the image will be nothing but my symbols. For example, I'll be having multiple images. I have closed it. For example, turn right ahead. I'll be having different images, thousands of images of turning right ahead, so that if that particular image has been detected, it could tell that it is turn right ahead, right? So same concept is applied, and here we have a data set which consists of more than 50,000 pictures of various traffic signs, which includes speed limit, crossing signals, etc., with categories of around 43 different classes, which means that like stop or 30 km per hour, 50, 70, like that. They have totally 43 different classes. So if you pass an image, it should find that what is that it has detected in that 43. So based on it, the command can be given further. So this is the limit for this project. So first we will be doing a data exploration, modeling, and training and testing and all should be done, but we haven't seen any CNN basics also, right? So let us see before going and implementing this hands-on. So let me just skip this part into some basics about what happens in a neural network in deep learning. Okay, can we start, guys? Are you guys interested? So if you know these basics things, we could understand how that particularly works. Clear till now? Yes, is it clear? Can we continue with this deep learning? So if you need to start with deep learning, it is suggested to go with a base of machine learning. Anyway, we'll cover that part here also. So we have something known as neurons and neural network, right? Yesterday we have seen neurons and neural network to mimic our human brain activity. So what happens here is, this is what a single neuron will look like. Okay, so it gets some input, it does some task, something known as wait and activation functions are done, bias gets added, and then output is generated. I'll explain one by one. So this happens in a single neuron, and if you connect it, okay, so they can work together by passing information. So this is a perceptron, which is a single layer neural network, and this is a neural network which is deep neural network or artificial neural network, which is a many layer network. Okay, we will be having a input layer, so information passes through this way, where we will be having an input layer and output layer. Output is for generating the output, input is for getting the input from you, like images, the numbers behind the images. And these neural networks layers are nothing but they will be intermediary to work on these. Okay, so these guys just perform some max, that's it, guys. So they pass information, they do some max. So how it is done? Okay, so in this neural network, you now understand that there are neurons, and if you connect it, they form layers, and you will be having input layer and output layer, and this hidden layer, it's n numbers, it's up to your wish. If you increase the number of layers, the process increases. So they have some disadvantage too, like overfitting can be done, but it's a vague term now for you. Anyway, so let us see some more basics about it. Okay, so what happens in a particular neuron? So let me tell you simply. So we have inputs. Okay, so inputs could be my columns, my rows, or my numbers which I have from images, right? I'll be turning them into array or matrix. We have discussed, right, images, how it will be turned into numbers, or you are having a CSV data set. So those numbers are taken. Okay, so first they get multiplied with this weight, something known as weight. Okay, so this weight is something known as weightage. It's a value. It determines how much importance should be given to this particular input. For example, so let us consider a scenario. Please ready to answer this question, guys, in chat box. If my input is 1, okay, and if I multiply it with 0.2, what will be my output? So for example, my input value is actually 1. Okay, so input is 1 multiplied by 0.2 is the weightage. So obviously your output from this particular operation will be 0.2. Okay, and similarly I have another one where x2 is going to be 4. Okay, and 4 I am going to multiply it with for example, let us give it as 0.1. Okay, 0.1. So the output will be actually 0.4 here. So this is 0.2, this is 0.4, but originally they are 1 and 4. Now could you see that their importance has been reduced here? Sometimes their importance will be improved. So this weight will be gets multiplied with x1 so that they are adjusting something. Okay, so what is that value? Optimal value is at first time. Okay, this concept of going front and back, there is, I'll tell you later. This process will be happening multiple times. So at the first time, this W1 will be randomly generated values. It's a random number getting multiplied. Their weightage is randomly determined, and then something known as bias gets added to avoid something like, for example, if x is 0 and if the weightage, if they multiply, everything will become 0. So the next process, it may struggle. So what happens is they are giving something known as bias. It's a constant that will get added, and then it passes through some activation function which does some math. Okay, so the weight are multiplied with your input and bias gets added. Weight and bias are actually random numbers for now, and an activation function is applied. So activation function is a mathematical function. It does some task like 0 to 1 or 1 to -1. They transform. Okay, so this is what happens in a single neuron. Then what happens is when they are connected, the output from this particular thing, after activation function is applied, a number will be generated. So that is given to this guy. A number will be generated from here, that is given to here, and then the process continues. Simple max. Here also, once the input is received, once again a weight will get multiplied, bias gets added, and the process continues. Okay, so this process of going from here, and in output we will be having some activation function which produces output. For example, like if I want to classify between dog or cat, it's called as binary classification. We go with different output activation function. And if we want to go with some multi-class classification, like we in this problem on traffic sign, we have 43 different classes. Okay, so that comes under multi-class. So in that particular scenario, I'll be going with a different activation function. So once this forward propagation is done, okay, so what we'll be doing is we'll be comparing. Okay, so once this process of from input, a random number, weight and bias gets multiplied, gone to your output. So now the output will be generated for your inputs. Okay, so this output is generated by your algorithm or your neural network, but this is our training data, which means I'll be having my original answer too. Okay, let us consider this is your original answer, this is your predicted answer. So when you compare, you will be getting some value which is going to tell you how much the error is. Okay, so based on that error, what happens is something known as back propagation is happening. So based on the error value, back propagation means values from here, from output layer will go to the input layer. So when they go, what they do is they will be updating your weight and bias. Remember earlier, okay, earlier I told you, right, this weight and bias are just random numbers. So first it is starting with a random number, then go to the output, compare the error, and then update your weight and bias through some max called as back propagation. Okay, derivative will be taken and the weight and bias gets adjusted. Okay, and then once again the forward propagation happens. It will check whether the error is reducing. If the error is reducing, it will change it furthermore, so that over a period of time, what it is trying to do is it is trying to do this gradient descent by optimizing the weight and bias, so that at one particular point it learns really well and produces an output which looks like, which is similar to your original one. If the error is less, then obviously it is successful, right? So this is what happens in a neural network, and these are some activation functions. Like sigmoid, tanh, ReLU, leaky ReLU, softmax, and linear, and they have some different properties in different scenarios. Like sigmoid will be giving you, if you apply this formula, that activation function, remember, weight gets multiplied with weight, input with weight gets multiplied and bias gets added, and then activation function is applied. So if it is a sigmoid, then the output is either 0 or 1 or between these two. Okay, if you go with tanh, then the result will be -1 to +1, between that range. If you go with this something known as ReLU activation function, it is a maximum of 0 between your input value, which means if your value is positive, then that is taken. If your value is negative, then the 0 will be taken because it's a maximum, and every negative values will be converted into 0. And we have leaky ReLU, and softmax is used for probabilities. This is for multi-class. Like if you have 5 different class, then who is having the more probable, that is going to be your output. In our scenario, it is going to be nothing but, in our scenario, we will be having 43 different probabilities, and from that, who is having the most probable will be the result. And so there are a lot of concepts behind this. So this is the base of how our neural network actually performs and learns on its own. If it's clear, I could explain how it works, particularly for images. Is it clear, guys, till now? Any doubts? Is it clear? Any doubts? Can we continue? Please post in chat box. So talking about the type of neural networks we have, what we have seen till now is called as artificial neural network, and then we have something known as convolution neural network. So if you have doubts, you could post it in chat box. I'll be happy to explain that. And we have RNNs, which is nothing but recurrent neural network. So these are some types where if you want to do it for images, then you have to go with a convolution neural network, where this is what we have learned till now. A separate process happens before that. Like if you have any particular doubt, please post it in chat box, or else we'll continue with CNNs. Okay, so talking about convolution neural network. Okay, so CNNs. So the reason behind why we go to CNN is when you turn your images into numbers, if you give it a raw, okay, this neural network, artificial neural network, is good for your data which is in a numerical format. So if you want to process your image and then do the same task, it is suggested to go with an additional layer which is called as a CNN layer, okay, convoluted neural network. So what does this guy does? Okay, yes, correct. After each cycle of forward propagation and backward propagation, after forward propagation, error is calculated, and then when it goes through back propagation, weights and bias get updated through taking derivative of your values present in each. Okay, with the help of activation functions, the values gets updated. So for that particular task, we have loss function, and we have optimizers, and in that particularly something known as learning rate is there. It's a wide concept, so I'll suggest you to take more time on this by taking this as an introduction and learn it furthermore. Okay, so talking about this convolution layer, it is a unique architecture with multiple layers inside of it. So what is this process actually? So if you understand this particular process, this I have told you some introduction, so you could connect these two. So we could jump into our project directly. So talking about this convolution neural network, it is used for image based classifications. Okay, so it seems like this layers, flattened layer, fully connected layer, softmax, these are output and input layers. We know this part, but what is this part? Feature learning of images. What happens here? So as we know, if it's a black and white image, we have single channel which has color from 0 to 255, and if we have an image which has 3 channel, okay, which is a colored image of R, G and B, red, green and blue, and we have different pixel values inside of it. So particularly in this convolution layer alone, okay, so we have multiple operations. For example, a filter is there where matrix multiplication will be done. Matrix is your input. For example, this is 663, which is 6 cross 6 image with 3 color channel. Okay, so a filter, once again, okay, I'll tell you what this filter is, and then some activation function ReLU is applied. So what happens here, let us see. This filter is nothing but you can define the size. It's like a patch. Okay, so what this guy does is, this is a filter. If you go with 3 cross 3 filter, then what this does is, it is going to select a portion of your image. This is your image numbers. It will take that particular guy, okay, and perform dot product multiplication, and what's the total sum, he'll place it here in this blue box. This is done and this is replaced here. So values are extracted from here, and then what he does is, he uses something known as stride. Stride means movement. Okay, so if it's a single stride, then after that red box, it is now going to take this green box, and that output will be stored here, and then this green next box, and then next. Okay, so it will move. Okay, so we have stride 2, which means after this red, it is going to jump 2 places and move here and take that particular value. So when you minimize this, you could see the size is also decreasing. Am I correct? Initially my shape of my image was 6 cross 6, but I am adding a filter of 3 cross 3, so the output is actually a 4 cross 4 matrix. So the size also reduces here. This is a format of patches are applied and then important informations are generated. So in some places what they have found is, okay, initially I had this matrix, when I multiply, they found that the information in the corner has been losing, okay, in this particular process. So for avoiding it, they have done something known as padding, which means adding an additional layer like zeros or any layers, so that what happens is, it will don't lose the information in the corners. Now this is, originally it was 6 cross 6. I have converted into 8 cross 8. A patch of 3 cross 3 is applied here, and the output is original shape of 6 cross 6 is obtained. So this is the process in a single convolution layer. Okay, so this is the filter operation. So once it is done, what happens is, okay, and padding also 2 layers are available to store more information. Okay, so once this is done, this process is, then it will give you matrix, then something known as this ReLU activation function is applied. Once again, if you ask me, okay, so I am telling that some filter is applied, some matrix dot product is obtained, multiplied, right? So who is going to give this number of this filter? 3 cross 3 matrix is fine. What's the value there? So that's the process, guys. Here also it is like weight and bias, which means random numbers. Okay, initially there will be random numbers in the filter. It will start from random numbers. So during the process, once again, what happens, they get updated in the back propagation. So over the time they will be updating their matrix numbers too. So finally they will try to find patterns and improve their process. So that's how this image processing works here in particularly CNN. So once it is done, ReLU is applied. As I told you earlier, ReLU will take all the positive values and negative values will be given as 0. Max between 0 and your value, input value. So zeros and positive values are taken. So what they try to do is, after this entire process I have taught you now is in this convolution process. So I could add multiple convolution processes here. So what they used to do is, after convolution process, they will go to max pooling process. So in what happens in max pooling is, you could set the size. Okay, so in that particular place, who is the maximum value, so that is taken and the size is reduced. Okay, for example, in this 4 2 cross 2 matrix, 9 is the biggest number. Among these 4, 7 is the biggest one. Among these 8 is the biggest one, and among these 6 is the biggest one. So this is output generated. Then this can be once again given to another convolution layer. So there filter is applied, same process ReLU is applied, and then once convolution you can go with max pooling, and then this is the process of convolution layer. But okay, so this is for image. Okay, so once you've done all these things, finally if you want to give it to your neural network, like what we have learned previously, the artificial neural network, if you want to give it to this neural network, you have to mandatorily go through a layer which is called as flattening layer. Why? Because till now what you have done is you are handling matrix which is 3 cross C shape and so on. Your neural network can't handle it. Okay, your artificial neural network, like input layer, hidden layer and all. So you simply, what you do is you do something known as flattening. This is what flattening is. Okay, so if you have matrix like this, it is flattened into a single layer. See here, 1 1 0 4 2 2 0 2 1. So if it's a 3 cross, like 3 channel, then it is converted in this particular format. This is flattening. Once this is done, okay, this is going to get connected to your fully connected layer. So once again, back propagation, forward propagation, then back propagation. This kernel size and all adjusted, the values gets adjusted. This process goes front and back. Over the time they try to learn the patterns, and then they'll update your output, like whether your output is a zebra or a horse or a dog. Here in this particular scenario, in our scenario, we will be having 43 different classes, and my algorithm needs to predict which type it is. Clear? Is it clear, guys? Yeah, so let us continue with the next one. So yeah, next is nothing but traffic sign recognition. So now I could, as I have told you, some basics, okay, some introductions on some topics. I could speak the technicality here. Okay, so we know that we need to train with images. We have image data set. So CNN modeling, we know that CNN is required, right? So we build a model to classify their images into respective categories. So the architecture here is CON 2D, CONV 2D is nothing but, it is nothing but convolution layer. Okay, and then max pool 2D is nothing but max pooling layer, and then something known as dropout. I'll tell you what it is later. And then again I'm going with convolution layer. Once again I'll go with the max pooling layer, and then I'll go into like I don't have it here, I'll be having a flattening layer, and then a dense layer with different properties will be applied there. Okay, so then we'll train it in different times. For example, we'll train it for 15 epochs. Epoch means, one epoch means every data passes from your input to your output layer and then come back. One forward plus backward propagation is going to be one epoch. So I have trained it for 15 times, 15 epochs. Okay, and what they used to do is they'll set a batch size also, which means here it is set as 32, which means that, for example, let us consider your data entirely, you have 64,000 data, okay, 64,000 images or 64,000 rows, whatever it may be. So you are trying to split them into 32 different batches. Okay, what will be the answer? 64,000 divided by 32 will be around 2,000, right? So for each batch you will be separating 2,000 random images, so that it's better to give part by part, so that you are not rushing entire thing into neural network and confuse them, right? It's better to go batch by batch, so that they'll try to learn more. And finally we'll be doing some testing. Okay, so let me go into the coding part. So this particularly, what they have done here is they have used this particular code in GUI for generating the result and using it in tkinter. So this is front end. So talking about the back end, traffic sign train. Okay, so for this particular task we'll be utilizing Keras, or TensorFlow is a library, okay, for deep learning, for getting your neural networks and so on. Okay, and so these process is nothing but getting your images. So I have my data here, my training data. See here I have 43 different classes. So for each class I have different image. Okay, I hope you could see this. So it's turned right ahead, very small image. So I have different images, as I told you. So this is warning. So these signs are available. Okay, and then I'm just giving their path, okay, to my training. For training, I'm taking it, turning them into NumPy arrays. Okay, splitting them into parts for our verifications. Okay, doing some pre-processing. So this is the entire CNN building portion. Okay, so till here, this entire thing is going to be creating your CNN and training part. So how it is created? You first will be using something known as sequential. So this is something like a thing which can add multiple layers. So if you want to create a neural network, you need some base, right? So that base, you can store it in a variable from the sequential. If you store it in model, you will be adding layers to it. I am adding a convolution layer with 32 neurons, okay, and a kernel size or filter size of 5 cross 5 matrix, and the activation function is ReLU, and the input shape is nothing but what is the shape of your image input, okay, for input layer. And then you don't want to proceed with input shape and all. So once again, from that output generated, I'm going with once again a convolution layer with 32 neurons, 5 cross 5 matrix, ReLU function, okay. And then I'm going with a max pool 2D layer with 2 cross 2 matrix as the size. Maximum values in that particular places will be taken out. And what is this dropout is actually is, I haven't told you about dropout. So in some places what happens is, okay, so this may lead to overfitting. Okay, so this training part may lead to overfitting because they are handling too much amount of data, right? So what happens is, in between, if you have a dropout layer, what happens is randomly they'll drop. For example, if I mentioned as 0.25, then out of 100, okay, for example, if it has learned about 100 data, it is going to remove 25 data from that. Okay, they are going to just forget. That's what they are just going to drop that, and remaining 75 will be passed to the next one. This is helpful to avoid overfitting. Okay, and then again I'm going with the convolution layer with 64 neurons now. See here, with the neurons increases, the process also increases. Here with the size, kernel size of 3 cross 3, and here also the filter 64 neurons with 3 cross 3 with ReLU. And then finally I am once again going with a max pool 2D layer, and also I am going with dropout to lose some information. Once I am done all these things, okay, if I want to go and create, for example, if I want to go and into my dense neural network, dense layers, then what I can do is I could simply go with a flatten layer. As I told you, flatten layer can be used for this conversion because their shape changes, right? So once you reach a flatten layer, you could add a dense layer. See here I am adding a dense layer with 256 neurons, okay, and then I am adding dropout which is 0.5, and then this is my final output layer, where how many classes do you have to mention it. I have 43 different classes. I need their probability. Let me go with 43, and softmax, since it's a multi-class classification. And then here is where I will be setting the loss value, optimizers and all. And then if you run this model.fit, it is going to train, where I am splitting them into 32 batches and 15 epochs will be trained. Okay, and this is the data. And once this training is done, I am saving that model so that I can use it later. So that saved model is available here. Okay, model.h5 will be taken. For example, here it is taking that, okay, loading that, and then here it is that h5 file. Okay, so that is what taken, and this is just some plotting. So this is what the training part, and then finally we are storing the model in this name traffic classifier. So that is stored now. Okay, so this is a h5 file which is a model file. So later on, if you want to use it in a new file, or if you want to integrate in this GUI, see here they are just loading the model for the backend, so they can make prediction. They have different classes based on the number they give, the output is taken. And this is a tkinter code based on Python for front end. Tkinter is a library or framework for front end GUI app creation, setting the geometry, title, and pathway for images, uploading it, predicting and showing the result. So what or where they predict is, let's go and check. Predict. See here they are calling the model to predict what is the images. Okay, so this output is taken, okay, and that particular sign is taken from your dictionary here. Okay, so this is what happens, and it is given into the label. So if you run this entirely, this is the process. and this 15 epochs training will be taking a lot of time. That's why I can't show you now. So let us upload an image. Let us go with something like this image. Okay, so it is predicting good, right? So this is based on the model's prediction. You can't expect it to be 100% correct all the time. So if you want it to be performing like that, you will be improving it in a way that it performs really well. So this is some glimpse of how AI is implemented in our real life and recent time. We don't have that much cars in our particular locality here, right? In US and all, they have Tesla cars which does this auto driving. Maybe in future we will be having in our cities too. So yeah, that's it about this particular project and how AIs are implemented in recent days. So any doubt in these particular 2 days which we have seen? We have covered a wide range of topics based on the introductions, and a particular application has also been dealt with. Is it clear? Do I want to talk or repeat about any particular topic? So if there is no any other doubt, so then we can wind up this session. Thank you for attending these 2 days of our internship or workshop on YouTube Live. So please post your reviews about these 2 sessions in the review link which is posted in the chat box. And please follow our YouTube channel. We are going to conduct a generative AI class. It is a full-fledged class, so it will be dealt with from basics. Each thing will be explained practically. So please make use of this opportunity. You could check our YouTube channel. So that's it, guys. Thank you. Thanks for attending.